Great. We are live now. And I shall share my screen next. Screen sharing this. Can you also my screen right now? Can you see the presentation? Yes? No?
Yes, we can.
Awesome. Okay. Wow. Hi, everyone. Welcome to the final hackathon day. And this is Cohere AI Hack for everyone following. So today I'm really excited to bring everyone back after a week of hacking and another week of evaluation and assessment. And just before we start the presentations and announce again the finalists, choosing the winners and coming to close with these events, I wanted to start with a very short opening remark to set the stage and help us appreciate how much progress we made in such a short period of time. So the Cohere AI Hack is an hackathon that is sponsored by Cohere and AI Saturdays Lagos in collaboration with five different communities, which the five includes AI Saturday Lagos. We have AI Saturdays Ibadan, Abuja, Arawa Data Science Academy, Carnegie Mellon University, Africa Data Science Club. And also we had partnership with Need Up, who provided us with the venue and for AI Saturdays in Lagos, and also eHealth for everyone for Abuja, and so much more. And the hackathon gathered a lot of interest. We had 239 registrants on DevPost. This is a big deal. And it's also diverse in the number of countries that's registered. We have the majority being from Nigeria, but we also had participants from Rwanda, Kenya, Germany, Senegal, and so on, the registrant. A lot of the registrants that signed up to participate in this hackathon are also diverse in their job specialty. We have data scientists, mobile developers, front-end developers, and product managers, so on. In addition, we have the diversity in the qualification from bachelor's to academic faculty, master's students, and this just shows you the richness of the people who have applied to participate in this hackathon. And similarly, like I've hinted when I started the talk, we also have diversity in the number of communities that are represented in this hackathon. And what is also very striking here is that we have so many other people that registered that are not from any of our one of the communities that we officially collaborated with. So we have like various number of people from various and amazing data science, non-data science community. So we're very, very excited, and we really thank everyone who took their time to check out the hackathon, to register, who were interested in being a part of this adventure. But of course, not everyone who signed up for the hackathon actually participated in it. And by participation, we meant people who signed up with their team members and formed a team. They have a team name. So out of the over 200 people that registered, we only had about 89 people who were part of a team, and there are about 25 teams. So we see here that we have great number of people from our Arawa data science community who are mobilized by the organizers, and several other communities that are represented in this, but maybe we don't see the prefix. So I just really wanted to take a moment to thank all of the community organizers that we partnered with, we are in collaboration with to bring about this great event, and also to thank everyone who shared it, who encouraged people to join in, who brought their friends to participate, not to do it alone. You're all the real OG, so thank you so much. And so even though we did have 89 participants, official participants, unfortunately, not everyone submitted their project. So out of this 89 people, we had about less than that. So we for the people who were like officially the people who submitted their projects were about 16, and 16 including one more team that did not officially register. So here you can see the breakdown from the number of total equals to yes. So those are the number of people who submitted their projects. And we see that we have about 53 participants who are from about 16 teams. So I just wanted to take a short pause here to really appreciate all of the teams that submitted. It's not easy to participate in an hackathon, especially one that runs almost entirely virtually with in-person hacking events. So it requires some dedication, some interest to follow up, and it also shows your grades. So you should be proud of yourself. We are, and we really thank you for taking the time, and appreciate all of you that submitted your work and to showcase your solution. That being said, we received 16 projects, all amazing projects, ranging from all trying to tackle various different problems. You know, we have projects, Dobby, looking at how to offer automated way in which people can label or do translation, label any kind of GitHub issues, like automatically label it. This would help developers speed up a lot their workflow. You know, you can also imagine you collaborate with like various number of people and they all speak different languages. What if you can just translate automatically and be able to understand that? I think this was a really fantastic project as well. So we also have like projects like from also Ticket Center, looking at how we can automate automatically tag tickets, you know, using Cohere classify to classify the different kinds of tickets that comes into the pipeline, and projects looking at how to be much more efficient as a student. How do we learn? Like the teaching or learning made easy. Internal health, assessing the health of individual, like their emotions, and how to classify so that they can better get help, and so on. Looking at critical problem in the society and trying to see how we can use technology to offer some solution that may be able to help make the society a bit better. So I mean, I could go on and on about all of this project, but I really would encourage every one of us to go to our projects directory, our gallery on DevPost, to look at those projects yourself, and you can see that like a lot of the projects gathered a lot of interest. You can a lot of people looked at it, voted for their favorite project. And some of the ones that are also shown here, we have Omoway.ai trying to help us with your own personal study co-pilot, right? Bible app, how do you read Bible much more efficiently? How do you moderate content, especially like on Reddit where you have a lot of toxic content? How do you detect and automatically moderate it? How do you translate from one language to another? How do you look for the most important information from video, like multilingual semantic search? How do you find documents much more efficiently, like find information in a document? All of these projects really blew my mind away when I was looking at it. It's like, oh, this is a really cool use cases. And I'm just so proud of the community for coming up with this, because the hackathon is extremely open-handed, right? We told you to build something cool with Cohere, multilingual embedding API. So it's really not very straightforward. What exactly should you build? But you've taken inspiration from various places from different domains and combined them to tackle problems that you think are very there to your community, to yourself, to your society, that has the potential to scale to different situations, scenarios. So I just wanted to congratulate every one of us, to say thank you. And I hope that you have been very proud about the progress you've made so far. And again, I will echo it right back that we are very proud about the project that you have submitted. So that being said, we like to say that everyone is a winner, which I deeply believe in, but we have to choose the top three, because we don't have all of the resources to grant everyone all these cool prizes that makes it attractive for people to participate in the hackathon. So for this reason, we have selected 5 finalists where we would invite today to give a short 5 minutes presentation. And I just wanted to, first of all, shout out to all of the judges that made this very hard decision to score the projects based on different criteria that we have listed on the website, to make sure that we choose projects that best maximizes all of the different criteria that we hope to see in a project. So I wanted to thank all of the teams from Cohere for taking the time to review each and every project, to give the score for all of the projects. And so thank you. And the next part that I wanted to invite a couple of the judges that are currently on call, especially I'll start with Roy, to maybe give some reflections about like what went through his mind while he was evaluating all of these projects, and maybe just to show you how beautiful the process of selection was. So Roy, could you give some reflections, please?
Yeah. And hi everyone, hi presenters, hi finalists. It's such a pleasure to share this special moment with everyone today. And honestly, yeah, like we have evaluated these projects, but right now it's still very open-ended, like to decide, because they're all really good in their own ways. And I guess throughout this presentation today, we'll be asking questions, and learning more about your project and your thought process when you sort of put this together. So we're still undecided, and we'll be making the decision as we go along today. But I think to take it a little bit back, like we have come a long way, Teju and the team, in putting this hackathon together. When the multilingual model first came out from Cohere, we recognize that like English isn't the only language in the world. I mean, I speak Mandarin, and that's my native language. And so, like we all have different languages that we speak, and we really want to put this model into the hands of like many other people around the world to build incredible products and projects that really we can take to market. And I think through this experience, we have seen that come to life. And, obviously a hackathon, you'll be able to see a proof of concept, but it is through that experience that you can see the feasibility of your work, and seeing how that can eventually bring that to your communities, your markets. And it has been an absolute pleasure working with all the communities involved, and Teju's team as well. So really, really appreciate that. I also do want to highlight that, this was a short period of time for hacking. So I really hope that during this virtual hacking, everyone were able to create connections and build friendships along the way. And, learn about each other's expertise and experience. I come from AR environment, like augmented reality background. And so, coming into AI, machine learning, I have so many things that I have yet to learn from many other people as well. And I hope this continues after the hackathon, especially what Sarah Hooker shared in her presentation. And well, feel free to join the C4AI team on their own multilingual research project. Pedro is heavily involved in that community too. So really awesome to see how this has grown out so far. And yeah, last but not least, I hope you all had fun. And yeah, really excited to see your presentations. We are evaluating this based on several criteria that we did share at the beginning of this, but I think ultimately we want to see how this can go further in the future, right? Like they're all good. So I personally would want to see what's next for this project. And yeah, thank you.
Thank you so much, Rai. So that being said, I wanted to remind us again what we are offering. So the first place we have three prices that are monetary, and we have up to 3 prizes that are based on Cohere API credits. And the first place winner gets to receive some amount plus 3,000 Cohere API credits, while honorable mentions would receive 500 Cohere API credits. We would now go next to the top 5 finalists, and yes, as some of you have been following our tweets and our posts online, we already unveiled this. Out of all of the 16 amazing projects that we received, these 5 projects stood out the most to all of the judges. One of them is called Document Co-Finder from Team B4. We have Omo Way AI from Team Solo, Internal Health from Cohere, Multilingual Semantic Search for Video from Team Zizis, and also lastly, Cohere Parallel Language Sentence Alignment from Arawa Data Science LMBF. And these are the finalists for, in order to pick the top 1, 2, 3 and our honorable mentions. We hope that the presentation that they give would also like help reinforce how to order these prizes. So without further ado, we're going to move now into the presentations. Just to remind you of the logistics again, we would have a representative from each team to give a 5-minute presentation about their solution. Then we would have another 5 minutes question answering period where the judges or anyone from the audience can ask them
Well, it seems
so
like
that once it's your turn to present, you can simply the opportunity to share their screen. So the first presenter that would have today would be Cohere by it's called Cohere Parallel Sentence Alignment by Arawa Data Science LMBF, and the presenter is Lukman Aliyu Jibril. And I'll stop sharing my screen now so that Lukman is able to share his screen. Lukman, are you on call and able to share your screen?
Yes, I am. Good day all. My name is Lukman Alichipe, and I'm glad to have the opportunity to present Team Arewa DS LMBF solution submission to the Cohere AI hack. So here are my team members. To begin, I would like to present a scenario. So we are conducting a research. Let's say you're conducting a research and you come across a source very important for your next work. And once you open it, it's in a language you don't completely understand. You try the translation and it's way off. You don't get it. So this is a common occurrence, everyday occurrence for low resource languages. And this is what brought us to present this particular solution to this AI hack. So our project is about using the Cohere multilingual embedding to align parallel text to give pairs that are most likely the best translations of each other. And then to review the problem statement, it begins with the scenario I presented earlier about checking a language and you can't really understand. So parallel data sets, you have resource poor languages. The parallel data sets for resource poor languages are like in two ways, in quantity and quality. And then it's a challenge because to train machine translation data sets, you actually need the quality of the data set translates automatically to the quality of the translation model. So, and since Hausa is a resource poor language and we speak it, we decided to choose it as it's a resource poor language from an NMP perspective, and it can translate well to some other lower resource languages, like other Chadic languages found around the West African domain. So the approach we used was using the Cohere multilingual embedding to align Hausa and potential English translations. So we have a document in Hausa and a document in English, and then we use the Cohere multilingual embeddings to align them, this particular sentence to the English corresponding translation. So it's actually a plug and play. So the Cohere multilingual embedding produces the 768 dimensional vector, and then we align them using nearest neighbor algorithm. So it's straightforward. Most of the work, the bulk of the work was done by the multilingual embedding. So the implementation, since it's a plug and play, we provided the script we used, and then everything is in a GitHub repo. Alongside that, there's a collaboratory notebook where everyone can try playing the code and seeing the files. Let's say you can even swap the documents to see, put your own sentences and see whether they work. So what we did is to get sentences in Hausa and then get the translations in English, and then you align them, pair them up. This translates to this translates to that, this translates to that. That was what we did. And the bulk of the work was done by the multilingual embedding API. And this was an idea we got from joining the initial sessions. We were a bit confused, not knowing what to do. We joined the initial sessions on how embeddings work. We were able to learn from there, and then checking the Cohere website, we were able to see the various implementations, the various things that they did with all their models, and then we came up with this. And then this is just a sample of the alignments. So in the left alignment, we have source sentences in Hausa, and the right alignment, we have the translations in English. So when we check the alignments made by the Cohere multilingual embedding model, they are almost perfect. Almost all the sentences are correct. They are all aligned perfectly. But on the other hand, we did a baseline comparison with LESA, and it didn't do so well. We'll say almost all are wrong, some are correct. So for those that can understand Hausa, I think they could see the differences. The next, we were able to use Cohere multilingual embedding for data science. We joined the Arewa data science community, and some are still students. Some of us are working in different fields, even in health sector and the rest. So we're all new to this. So once we came in, it was a bit confusing where to go. So we decided to all go to the website to search and then brainstorm after coming back to discuss with the team. So upon checking the Cohere website, we were amazed by what we saw. The endless potential in natural language processing, seeing how they have different things, classification, different prompts, and another thing that was so helpful in helping us with the implementation is documentation. everything is arranged straightforward, even for beginners. People with limited experiences could learn and try to implement something. And the playground too was amazing. You just put it, and they even give code snippets for you to try yours in another environment just to see how it works. And then it also helps us see how it's possible to build something even with limited resources, because even with limited skills, because all the resources are provided by Cohere. And then to me, the greatest take home is there are no limitations. Before we joined this Cohere stuff, we didn't have any experience, but joining, we were able to come up with an idea and at least bring out the implementation and to see how we can propose how the idea is good. And then the next thing I would like to talk about the future work and next steps. So the since it's an idea that we have and we used the model and it was quite good with a very high F1 score when we tested on the Flores database. On the Flores data set, it's actually something that could be quite useful because the machine translation services, when we look at parallel data sets for low resource languages, some of them, the quality is so poor. And using this multilingual embedding, what we've seen is something that will help. And when you adapt and further train the model, and even maybe include a model completely trained in the initial low resource language, Hausa in our case, we could combine them and produce something like almost perfect, which could be used in things like language learning tools, cross-lingual search engines, multilingual customer service, and the rest. All these things are things that exist for high resource languages, but for low resource languages, it's something that is a bit lacking and it's something that we're looking at. And then to conclude, the machine translation community could benefit tremendously from using Cohere's multilingual embeddings for parallel language syntax and alignment. And potentially, more importantly, for low resource languages, it was able to work so well with Hausa. Like it was able to work so well with little or no training, and it worked so well. And imagine the potential for other low resource languages once you adapt it and make it better. And finally, I would like to appreciate the organizers of this hackathon for the opportunity, for allowing us to come in contact with Cohere's resources and for giving us the opportunity to present in this forum, to present to this distinguished audience our humble solution. Thank you so much. And I would like to implore the audiences to try out our repository, try out our code, the link on our project lab to see how it works. All the things, even including the baseline assessment, were done. Thank you so much.
Well, thank you so much, Lukman, for the presentation. A virtual round of applause. Thanks, right? So now we open it up for questions. Do we have any questions for the team? Again, the question can come from the judges or from the audience. Right, please take it away.
Yeah, I just want to make a couple of comments and maybe a follow-up question. I mean, first of all, Luckman, like, well done. I think when I was discussing this with the judges as well, like, I personally found that this is going to be useful in terms of the research capacity, but also sort of having these data sets to lay the groundwork for future applications that will be built using these findings that and given more time, this will go a long way as well. And I think this is an innovative idea to gather data sets of similar sentences from one language to another. So, you know, this could work for, yeah, as you mentioned, right, language rephrasing task or just gather data for a given subject that we're interested in. So I'm really excited to see what the next steps are for your team to sort of further sort of explore this beyond the hackathon. So what are your thoughts around that with your team? Any plans in the near future to sort of build this out further?
Yeah, we discussed with our team regarding building it further, and our plans include trying to see how we can make it as perfect as possible. Let's say, okay, it's around like 95% when we tested the translations and the rest based on what we know and using the Flores dataset. So the plan is to see how we can maybe train a model completely, let's say in Hausa, so that it can understand the context, the grammar, and things like that. So things it misses, when you combine it together, it's going to be better. And then we can look at maybe things like translations that are better and things like that. So we are still thinking around it with the team. So regarding that, what the main target is to see how we can make it as perfect as possible, because it's almost there, it's excellent, but it can do better.
Yeah, I'm very impressed by the score as well, like to see that sort of shape out. And this is the reason why we really put this model in the hands of the community to see how that sort of builds out along the way as well. And please keep like let us know how the progress goes, you know, in the next couple of months. We would love to sort of follow your journey as well and support on sharing this out.
Thanks, Rory. We have a question from Idris. Idris, go ahead.
So thank you for this wonderful presentation and for this wonderful solution also. So my question is also along the line of Roy's question. I know firsthand WMT usually rely on this laser autoencoder to generate potential parallel sentences for mostly low resource languages. So how like do you know, like because what you used in the hackathon here is an API that may have limitations. So do you like have you contacted the Cohere organizer to see the possibility of the deployment of this like in a large scale so that all limitations are reduced, especially for the low resource community to be able to use this solution of yours to develop better translation systems?
Oh, thank you so much for the question. Initially, when we were running this, we got this course for the Cohere model, and it was so nice. When we tried the laser model, it was so cool. The translations were off, the F1 score was so low, and when we discovered that that's what was used for, that's what's normally being used in the machine translation community, especially for low resource languages. So we actually discussed about contacting the Cohere people, but we didn't actually go through with that. So I think that's something that we can also explore, but it hasn't been done, but it can be part of our next steps. Thank you for the question.
Yeah, thanks, Citrus. So I have a question for you, Lukman. So the F1 score you showed was benchmarked on Flores. I wonder if like you showed some example of how it's really good for translation for Hausa, but we also had like similar comments from organizers of how Harvard saying like that try to like generate some text in Hausa and it was not great. So I wonder where it breaks from your experiment, you know, is it like small phrases good to translate, but once you get into complicated conversation, then the translations are not like one-to-one, it starts to make mistakes. I'm just curious because it's really important to benchmark the models and also like to train to see the potential and how to improve upon it. So I imagine that the translation on Flores is maybe really good. It's probably simpler or easier, or like a lot of training instances like maybe from like already exist in the model. So again, my question is just like how robust was the translation to different kinds of data sets that you exposed this to from the language that you care about?
Okay, sorry, I didn't get the last part. But from what I've seen, the Flores sentences, when you check them, the English and the Hausa, you have a range from the short sentences to the longer sentences, and it did well. So it was able to, like 95%, it was so good, and it's a range from long and short sentences. It did well. We were amazed by that, because actually initially I tried the language detection on Cohere. So as I tried to do that, I found it that sometimes when I put some Hausa words, it kind of, because there are some languages that are related, maybe you have Indonesian and the rest having the same languages, it could not detect. So that was why it was really amazing to see that it was able to align those sentences well and give. And really, the sentences is a range from short to long, and for it to get up to around 95% means that it did well on the regardless of the length of the sentence or the content.
So the reason I'm asking the question is that I don't know all of the data set that Cohere multilingual embedded was trained on, but I imagine that maybe one of those data sets are Flores. So you can imagine that it's already seen that data set, and so it should have like it's like when you train your machine learning model, and it's like the training set. You would expect it to get everything right on the training set. So I don't know if this is the case. I'm just that's why I'm saying that. Do you have like some test sentences from you that you collect, like maybe from other sources, and then that you also have the parallel translation for that maybe you manually curated, and to now see how perfect the translations. That would be like a good thing to a gut check. But again, like this is already extremely impressive, like you mentioned, compared to the other model laser that you benchmarked. So I don't want to take too much of your time, but it's just
okay. Let me just answer that, please. So
yeah,
in my presentation, I gave a series of sentences. Those were custom made by us. We decided to put the sentences and the translations, and it did well. That was what I explained initially in my presentation. So that was I even asked other people to send sentences, teammates, other colleagues, things like that, and it did well. So it's not like we only used the Flores data. We did that to get a score, but for checking, we used our own sentences, and it performed excellently. Thank you.
That's amazing. Then yes, so now we would move to the next presentation unless there is a question that is very urgent from the audience. So again, let's give our speaker Lukman another virtual round of applause, please. And the next speaker is Paul Okewumi from Team Omowe AI, Team Solo. They'll be sharing their work with us, and you have 5 minutes, please, and another 5 minutes for question and answer. Thank you.
Okay, hi everyone. Can you hear me? I'm Paul Okewumi from the Team Solo. I'm presenting Omowe.ai. Omowe is in Yoruba means scholar. Okay, so so we know the challenges that students face when they're in school. So there's a challenge of always reading through large documents because you have to cover your schema, you have to cover syllabus, or you have to write tests consecutively, or you have to write essays and you have to write it and pass the plagiarism check. So all this is what we considered when building Omowe.ai. And traditional study methods often fail to fully exploit the vast amount of information available in study materials. So imagine you can have a personal study assistant in your pocket or at your fingertips, where you don't have to always Google, or you don't have to always flip through large PDFs. A tool that is capable of understanding the meaning behind your questions, and you can feel free to ask questions in any language, your native language. So wouldn't that be awesome? And that was what prompted us to build Omowe.ai. So that's where Omowe.ai comes in. It's a suite of AI-powered study assistant tools, and we call it your study co-pilot. It comprehends the context, intent, and relationship within your study materials. So this enables you to discover knowledge like never before. So how does Omowe.ai work? So we have, sorry, I'm going to be switching. So here's a simple interface we hosted on Hugging Face Spaces, where the first on our lineup of tools is the document search, where you can search. So we wanted to mimic the way this is in the real life, but we couldn't find large text on a particular domain. So we decided to use Wikipedia, which is an open knowledge database. And we also have we're able to embed documents in 4 different languages, although we can do more with the Cohere multilingual API. And this document cut across history, linguistics, philosophy, and government. So let me give this a trial and to show you that this actually does what it says it does in different languages. Let's test with English and say, okay, I have documents in Yoruba and Igbo and Hausa, but then let's test and say, who is the current president of Nigeria? This pulls out a Wikipedia page telling us Are Ile Nigeria, which means president of Nigeria. You can see the answer right here where it points out Muhammadu Buhari, and he has been president since 2015 and so on. You can also go ahead to translate. So this is the English translation for guys that who aren't in who are influenced in Yoruba. And you can also go ahead to click on this source URL, take you to where this was pulled out from. When you to give this another try, I'm going to go ahead to ask the same question in Spanish and see that it gives you the same thing. So this means that you don't have to worry about the language you're comfortable with. In my class or in my school, I know guys that don't ask questions because they don't know how to properly phrase their English. So you can go ahead to just be flexible and ask. So this gives us the same thing. And this shows you that the multilingual model is actually doing what it says it does. Let's do something a little bit philosophical. So I'm going to ask Onye Buchineke, which is a Yoruba, which is the Igbo term for who is God. So let's see, this gives us Chineke. Chineke means God. This gives us Chuku. This gives us, so these are like other terms for God. Let's go ahead to include Hausa in our results. Okay, so yeah, we can go ahead to try other languages and it does what it says it does. I'm using Cohere's multilingual model. We're able to embed about 10,000 Wikimedia pages, and this could do a lot more. So say you don't have your document embedded, you want to test what we have, you want to give it your own document, you can actually load in your own document and you can actually ask it questions based on your own input document and it gives you a response. So we'll come back to the response of this, but then let's go ahead. So this is the response, talks about Nigeria getting a name from the Niger River and the likes. You can also summarize text. So you want bullet points, or you just want a short summary of a large chunk of study material. You can go ahead to generate summary. And it even gets better. You can go ahead to generate questions to help you practice. And this just tells you that AI is doing a lot for us here. And for paraphrasing, say I have a huge chunk of text of essays that it's not well written or it's not pronounced, it's not spelled properly. I can go ahead to use our paraphrase feature to help you to paraphrase your sentences, and it tells you the inputs or the corrections made. Yeah, so let's move on to how we're able to pull this off. So we built the front end using Gradio. Gradio just helps us to create very easy UIs, and the front end just takes in a query text and it shows you the output results. For the document embedding, we're able to embed Wikimedia text, about 10,000 in 4 different languages. This could be more, using the multilingual API, and we store this in a Pinecone database. We're able to do summarize using Cohere Summarize API, and we're able to do the paraphrasing and the question generation using the Cohere Generate API. This was impossible to do without Cohere. Okay, so our business plan is just to make it a freemium model for students, of course, because it's not easy to get students to pay for stuff. They see how good it is, then we can move on to premium. We can also do some partner with institutions to make this personalized. So if you go to MIT, there are resources, we can have it embedded, and so much more can be done from this. For future development, because we are able to only embed 4 different languages, and while we can do over 100, we would like to expand this using, this is going to take Cohere's API credits, but then this is what we plan to do so that you're not limited by language. If the knowledge you're seeking is in another language, you can always get it by querying your own native language, and it fetches it for you. We want to integrate online libraries and databases, and also databases from institutions, and also add adaptive assessment, meaning increase the difficulty of your tests as you're getting them. So increase the difficulty for you to get better knowledge. This was brought to you by Team Sulu, and thanks for listening. Do well to try it out.
Wow, this is really great work, Team Solo. Thank you so much for sharing your solution with us. I'm going to start with a quick question, then we'll move on to Tayo to ask a question. You did, first of all, you showed us an example of how it can translate between multiple languages, but on this flow, I don't see translate. So I want to ask you how you're doing the translation. What
Okay,
technology are you using for translation?
okay, for translation, we're using Google Translate. So we're passing the input text, then it's automatically knows what language and does the translation for us. Another option we wanted to go with was using Cohere's language detector, but we weren't sure it was going to do the translation for us. So that's why we went with Google Translate.
Thank you so much, Paul. And so here you use the Cohere embed to embed all of the documents, and then once you had the embeddings, you use the
Store them and Pinecone, and can always
okay, and all this other cool stuff. All right, thank you. Tayo, please go ahead with your question.
All right, thanks, Teju. And thanks again, Paul, for your presentation. This is a wonderful project. So very well done. What I want to say is it's not really a question, just something to think about for future work. So it's on the case of accessibility and inclusion, basically. So there are people that probably, yes, do not understand English properly, but some people also have a challenge of reading visually, and there's also the case of people that are visually impaired. So I would think that one of your future goals for this product should be including a text-to-speech feature, so that you can read out whatever is generated or read out whatever prompt is fed in, just for confirmation and to make sure that everything is working right. But otherwise, nothing else comes to mind in terms of asking a question, just that suggestion.
Thank you very much for the suggestion. We're limited to, not an excuse though, we're limited to 7 days. So like we try to prioritize what features to add and what to, but then it should be in our future part too.
Yeah, I totally understand. So that's why I said for future.
Yeah,
but it's
thank
all
you.
good. Yeah.
Oh, thanks, Paul. We also have another question from Said.
Hello.
Hi, Said.
Yeah, so that's a wonderful solution and a wonderful presentation. In fact, I love the model description. And then while doing some of the example, I don't know whether you have like an evaluation mechanism in which you evaluate how effective the solution is. Like, will you, on a scale of 1 to 100, how will you measure the effectiveness of the solution?
Okay, so effectiveness in the sense that is it in the sense of the response we get or how useful it is? So okay, can you clarify that?
Both understanding the question and giving out the response.
Okay, understanding the question and giving out the response. So the idea is that you don't have to be comfortable in speaking, say, English. You can be very comfortable with your own native language and you ask a question. Then Cohere's multilingual model does it knows what questions you are asking and it knows how to translate that to an embedding and fetch. So we have predefined document that we've indexed in our vector database. Once you ask a question, we find the document that is closest to answering your question from our vector database, then this is being displayed. So there's a situation where if the answer isn't present, you wouldn't get what you're looking for, but you get the closest to your query.
Well, thank you so
All right,
much. We have to.
Thank you. I just give him a small suggestion. Sometimes you evaluate your model so that sometimes you can create a benchmark, or perhaps so that you can allow other people to also improve on it if there's any lacuna. along the way.
Cohere's
Yeah, it's a
multilingual
wonderful
model
project.
is open, so I guess we can work on improving it.
I completely
Thank
agree, Said. It's always great to benchmark to be able to put a number on how well it does work. So this is something to consider, Paul, just to make sure that the system is doing at least what you expect it to do, like quantitatively. We also have like one question from JJ, and I think we take that real quick. He said that he has noticed that your QA module is currently providing paragraphs that contain answers using question document similarity instead of providing the precise answer itself. If you were to make improvements in this area, what approach would you take?
Okay, so because of the time, I couldn't ask a second question. So the second question in my demo was supposed to be asking when did Nigeria get their independence from the input text, and this is going to give you a one-line answer. If you check the query was when did Nigeria get how did Nigeria get her name and who named her? That was why we had longer text. But then if you just want a simple, okay, what year was this done? It's going to actually just give you 1960 or so. Like, I'll suggest probably trying out more questions, and I'm open to feedbacks on getting how verbose our responses are, so we can work on that.
Well, thank you so much, Paul, for entertaining all of the questions and providing answer to them. So we would move on to our third presenter today from Team B4. They'll be talking about their solution titled Documents Co-Finder, and the presentation would be by Kwandwo. Kwandwo, I hope I pronounced your name right. Please correct me if not.
Okay, hi guys. So my name is Cohere Ejaponintra, and I'm presenting for Team B4. My teammate is Wendy Suman. Okay, so yeah, so we are presenting Documents Co-Finder, which is a cross-lingual semantic search tool. Yeah, so the problem is that the internet has a lot of information. Sometimes finding the right information from the right document for a specific query can be difficult, can be time consuming. And when you add in the factor of multiple languages, the problem becomes even worse. So this can lead to reduced productivity and substandard information retrieval, which ultimately leads to frustration. So what we are proposing is a tool that's going to help you surface the information you need from documents. Sometimes it could be your own documents, maybe because of confidentiality, you cannot release this to, on the web or into some foreign system. So you want to have the autonomy to set your own documents, and that we don't care about what language the documents are written in, really. So our tool locates and translates the information within PDFs quickly and as accurately as possible. We're using semantic search based on Cohere's multilingual embedding, and we also used Cohere's re-ranking API. It's in beta, it's pretty new, but it's wonderful. And so our tool sorts through your documents and to return a human-friendly response given to the query. And for the documents that were surfaced, we've also integrated machine translation, so you can manually verify the authenticity of what you are reading. So this is how it works. I'm going to pull in a document into the system. This document I know is about nutrition. It's in French. Based on my little Duolingo, I know it's about nutrition. I'm going to ask it a question about how much energy is produced when you eat your breakfast, right? So it's translating the stuff, generating output for us, and we see the response here is 25%. We can clap for it and say it's moved on. We also see French and English translations for the relevant, places where it found this information. You see this 25% here. And I can verify for you, even using Google Translate from this paragraph here, that indeed it says breakfast represents about 25% of dietary energy intake. So we see that it's doing what we wanted. And you can verify based on the various answers it used to generate whether or not the answer you got is true. Okay. So under the hood, there are four main things that are happening. We have coheres, embeddings, re-rank and generate endpoints working. We have a translators API, which is used to generate a translation so you can verify yourself. We have Streamlit, which we use to create the demo, and we have Annoy from Spotify, which we use to do the indexing and the searching. And this is how everything comes together. You pass in your documents, as I did, the text is chunked, and we use Cohere's embed, the multilingual embedding, to create the embeddings. And then we track each embedding with some metadata, so we can tell you which page was your information found on, and that kind of thing. We create an index from the embeddings using Annoy, and then we now take the user's query, embed them using the same multilingual embedding, and then we do the dot product similarity scoring in a noise vector search. And that's going to return some hits, maybe about 5 hits or more. And what we then do is we pass it through Cohere's re-rank API, which is going to give us, is out of the similarity scores, the top results from the similarity scores is going to further narrow down to the top scores according to Cohere's re-rank API. It's just one line and it makes a whole lot of difference. Then we pass all the hits through the translators API so you can verify the final response. And then we generate a user-friendly response using co.generate. So that's the final response that you see at the end of everything. A few lessons we learned while doing this is the multilingual re-rank, it made a huge difference. So like I said, it was just one line and it significantly improved things. So I know it's in beta, but you should try it out if you are playing with Cohere's APIs. The logical process of prompt engineering reduced some of our frustration because the generate model is an LLM under the hood, the command X large, and we had to tweak it to get it to produce the best results in the most concise manner. And then the dots product similarity score, that was new to us. We've been working with things like angular distance and cosine similarity. So this was a new learning for us. What we hope to do in the near future, and we want to enhance the search algorithm. Right now, it's purely semantic search based on similarities, but we also think we can create a very good hybrid search model using things like entity extraction combined with keyword search. So even in the query, find certain entities and see how we can use that to narrow down our search even more. We want to expand the product to other documents types. So not just PDFs, and I'll show something about one of the improvements we are doing, but other document types, Word documents and PowerPoint presentations, anything really that is text, we want to be able to work with it. We want to upgrade our API access. Right now we are using the trial key. So as most of us know, we are limited in the amount of work we can do with the API. We also want to optimize the server. Right now we are running on Streamlit, so we have like 1 gigabyte of space in memory. We intentionally keep everything in memory so that once it's done, it's cleared from memory and you don't have to bother about, is my confidential document still online? Yeah. And then we want to expand language support. We want you to be able to make your queries not just in English, but in any of the languages that is supported by the multilingual embedding. So we want to expand to that. A proposed business model is a pay-per-use model with premium features. So like if there's a company that wants to persist their information or I don't know, scan larger documents, we've put certain limits on the system. So we would like to put that as a premium feature. So I mentioned a few improvements. One of the things we've tried in addition to, so this is the original Documents Co-Finder, but one other thing we've tried is searching across websites. So there are 2 websites here where we want to look for information. This is the Cohere's documentation, and this is a BBC article. The Cohere documentation is in English, so I'm going to skip and go to the BBC article, which is in French. And if you understand French, well, I can help you. It says une femme surveille grass, something. Yeah, it's actually saying a woman survives on a bottle of wine for 5 days in the Australian bush. So we want to see whether we can get that information from a website, not necessarily from, from a document that we had on our system, so we can expand the capabilities. Oh, sorry, I just posted the link again. The question we actually want to ask is here. what did a woman survive on while in the bush? And it's the same process, but this has a few algorithmic advantages so it's a little faster. And so it says she survived on sweets and drinking a single bottle of wine. As usual, you can go and verify both in the original language and in English what happened over there. And here it says she survived in the Australian bush by eating sweets and drinking a single bottle of wine. So we see that once again, it's working the way we hoped. And thank you for your time. Any questions are welcome.
Well, thank you so much. Can we get a virtual round of applause for Team B for this is impressive work. Thank you. I also did try the demo with my own document because I was curious, and I was very, very impressed that's how well the exact information I was looking for was retrieved. So that was quite impressive, and well, thank you.
Thank you very much.
Do we have any question for Team B4? Any question?
I have no questions, but I have a comment.
Okay, please go ahead.
But this was a really
comment.
fantastic job. Like really, really awesome. Like really love to see this demo like come to life as well. Like, I mean, I understood that like this was taken inspiration from one of our champions, El Neo, co-founder, but like with a different added element, right? Like of like multilingual and also re-rank, taking this whole project to a new level. Like just all agreed that like the code was clean. It was a clear vision, well description in terms of tech stack. So like, I just want to say well done.
Thank you very much. Thank you.
Yeah, I think this is fantastic. It's really great that you were able to build on top of another person's work who also, as I understood, has won a hackathon or participated in the Lab hackathon, and I think this is just fantastic. It's a completely different use case, but similar idea. So,
thank you.
Great job. Do we have any other comments, reflections, questions for Team B4?
I don't have a question, but I just have a comment also. I think the presentation itself, not the project, but the presentation was really beautiful. It was nice to follow along with you, Quadro. Nice job.
Thank you. Thank you, Abdul Ghaffar.
Great. So I think that's it for this presentation. Thank you again. Please another virtual round of applause for Team B4, and then we go to our next presenter, which is from who's from Team Coherent, and the name of the project is called Internal Health, and it will be presented by Alleluia Darasimi Oludele. Alleluia, are you able to share your screen?
Can you see my screen now?
Yes, perfect.
Okay. About to start. So, good evening, everyone. I really appreciate Cohere for organizing this hackathon, and I'll give good thanks to you, Tejimola, and also George. It was George that explained how to use these APIs on Friday, and it's kind of inspired us to work out and do something with it. And then we came up with the idea of internal health. That means the mental health of people, combating mental healthiness from a social media perspective. I would love to share a brief story. While I was on Facebook, there was a story of a lady, and then this lady has been posting something suicidal over time, and then all of a sudden we just heard that she had died. She's dead. What happened? She committed suicide. And the funny thing though was that people were not really paying attention to her emotions, to what she's going through as at that time, until she died. This is something that we feel is very, very bad, and we know that social media should be able to work and fight against mental health illnesses. There has been insights and also developments in this area. Facebook has an AI-powered system to identify intentions and emotions. We also have from Twitter. Twitter uses an algorithm to check whether videos are suicidal or something. But we know that there are stuff that still needs to be done. There are things that we know that we can do. For example, from a statistic that we have seen, and we see that 800,000 deaths occur annually from suicide. Suicide is the leading cause of death in the US. Suicide is the second leading cause of death for people of ages 10 to 34. And also, coming to see the social media perspective, around 69% of adults in US use Facebook, while around 23% use Twitter. On Facebook, around half of the users post at least once a week, while on Twitter, around 1/4 of users use tweets at least once per day. This shows how much people use social media, things that they can't tell you, things that they can't tell their friends. They put it out there online. They make you see that this is what we're passing through, but yet people don't really pay attention to them. So what are the things that we know that we have to do? How can we provide a way to help analyze the emotional part of posts and detecting the mixes? The mixes in the sense that a post might have different grades of emotions. How can we get to find an holistic view of what this is and help people as a result of that? This doesn't just apply to suicidal posts, but also happy posts too. Or if you are happy, what can we do for you? How can we generate contextualized responses based on this post? If someone posts something that he feels happy about, how can we reward the person and then give a sort of an encouragement to the person? If someone posts something and is sad, how can we reply to the person and give the person a source of hope? Also, healthcare professionals, this is something that as a medical student, I feel we also have to put some work into. How can we leverage data insights for better health? Holistic health has to include both the physical and the mental part, and these things actually have an interface where they interact. Why the doctors are actually facing the physical part? Why can't we leverage our social media networks, which is very, very widely used, to be able to generate insights based on the trends of posts of people and get them to understand how these people think, what they're actually going through? How can we help them? How can we give the healthcare professionals data-driven insights to be able to help treat the patients better? And then we came up with a four-pronged approach, which includes Cohere API all through. We start with sentiment analysis and classification using Cohere to analyze the emotional content of posts in social media and identify people who may be at risk for mental health issues. Also, machine learning algorithms can be used to predict the physical actions of people based on the data analyzed over time. This will be used to provide insights for healthcare professionals for holistic treatment. Also, we also bring the social media platform into the forefront of fighting against mental health instability, and our text generator that provides simple and effective way to analyze and detect context to generate responses that match emotional trends of people in their online activity. Our text stack used, we used Cohere, Python, Streamlit, and Render. Our Cohere is a very, very good, it has a very, very robust API system that are pretty good. And Python is our language, and just as the design of Python is, everything has to be simple. And so was our solution. And using Streamlit, we use it to visualize, to deploy our app, and also on Render for streamless, for fast deployment and then ongoing deployment. So how do we use Cohere multilingual API in our solution? We expand the capabilities to effectively identify and respond to distressing content in different languages. Cohere's pre-trained classifier turned out to be powerful even when trained on a small amount of data and worked with different languages. I really give it up to Cohere for this because they really worked a lot on this. Their classifier that even we worked with only about 50 data sets, even though we had about 6,000 for both training, for validation and for testing, and then it was able to give us something that was what we are actually working on. Also, the Cohere generator was to generate content that matched the post in various languages apart from English. Lessons learned from Cohere: as complex as its problem must be, the best solutions are always simple. No matter how complex this problem is, we should always try to find the solution that is simple. This also opened our eyes to the art of creative problem solving, especially in the aspect of mental health and then health-related issues. The Cohere API was easy to use, though we were able to train with only 50 data sets. We also saw the power and learned how to integrate Cohere APIs to solve the problems proposed. Our future plans include training with vast data and improving the multilingual capability. We are going to be training with vast amount of data, both in English and various other languages, introducing more emotions because we discovered that we use 6 emotions for this project. There is a range of emotions, and then we are going to be able to identify mixes and also threats based on those emotions based on those posts. A database to store data and analyze over time for retrieval so that we'll be able to provide data-driven insights for mental health professionals based on what we've analyzed from our database. And also we want to integrate it into a social media network because we believe that social media has a lot to play in fighting against mental health instability. Conclusion, we believe that this project can revolutionize the way we think about mental health care, and we are excited to see it through to the end. This is our team. We are Amalilu Adorasimilidele, we have Timothy and Tosin. I'm a medical student and I'm also into data science. Timothy is a computer science student and also a software engineer. And Kudus, Tosin is a data and information science master student and also a software developer. Thank you. Now off to our demo. So for our presentation, the pitch that we made last week, we used demo post, but then we want to show you a real life post. Here is a post here from Facebook of a lady, Dana Lad, who actually had plans to kill herself. And then we will copy this post. Incoming. We will copy this post here. We want to use something that is real. Then come down here to our internal health site and then paste this. Then, so let's wait. It's going to analyze and then drop our reply now. So here is the analysis of the emotions. This person currently has a feeling of sadness. Obviously, from the post, let's check the post again. The post actually showed something relating to sadness. I had plans to kill myself tonight, and then because she was into crypto, and then she lost a lot from crypto. And also, this visualization here actually showed us something about what are the trends of emotions here. And also, we have a way of saying how accurate it's. For example, the sadness here, it was 54%. From the value here is 54% accurate. And the reason why this is we're only able to train with 50 pieces of data. But yet with this, because of the pre-trained nature of the Cohere classifier, it was still able to produce this amount of accuracy. How much more when we now train on larger amount of data? How much more when we now do something greater with Cohere? Let's come in. So now let's see this reply from the Cohere. I'm sorry to hear that you were considering suicide. That's very brave of you to share your feelings with us. It's clear that from your post you are going through a very difficult time and that you are not alone in feeling this way. I can understand why you should be tempted to take pills. It's easy to get caught up in your emotions and feel like there's no way out. But please know that there is help and support available to you. You can talk to your friends and family about how you are feeling. They may be able to offer you support and understanding. You can also seek to help from therapists and counselor. They can help you work. So that's what it's about. Then we can still see that that's a feeling of sadness. And then from this, we know that we can, by the time we analyze this post over time, because this is just the demo site and it needs a social media network. And we can't just infringe on people's data and rights and then just start getting their data and scraping their own page, but we are just able to copy this by integrating it into a social media network. You can be sure that this is going to be producing better accuracy, and that's what we are after, to use AI and Cohere. We use Cohere throughout, and then by this, we know that we'll be able to provide better solutions and help people have better healthcare, both mentally, physically. Thank you very much.
Well, thank you so much, Hallelujah, for your presentation. Can we please have a virtual round of applause for the presenter? And we will only take maybe one or two at most questions because we're running out of time. So if you do have a question or a comment, please feel free to ask or to make a comment. Okay, so I will start with these short comments. When I was reviewing the project, yeah, you should talk about social impact. How do you mean, Tayo? Could you elaborate?
Oh, no. I was just making a comment, like this is a very solid example of using AI for social impact and impactful use of AI. So that was what I meant. Well done.
Yeah. So yes, I completely agree that this is the case, right? So I was also I had mixed feelings, right? This is great. It's to help analyze emotion, but it's also a very critical project that one needs to take care of. Like here is a point where you cannot make mistake. Let's say, like I've seen examples like from online where the AI pal end up giving some advice that led to an outcome that we wouldn't want. So, I actually tested this a bit, like with different kind of prompts to see what comes out. And so far from my prompts, nothing came out as being disruptive in a negative way from the AI. So I think it's really is robust, and I would really encourage you to continue to like test this out, and maybe a natural way for me would be to have some health practitioners that know what they're doing, to kind of like as an aid to help in their workflow, not like an everyday user use this emotion without any guardrail, so I guess this is just personal feeling, because I'm always very very cautious about this subject, and how much of technology that we should automate without having some extra person, some human in the loop to help verify and to make sure that everything goes well. But this is fantastic. Like I said, I tried it out and it was really, really nice. Most of the responses I got was supportive, trying to encourage me not to do whatever it is I said I wanted to do that maybe harmful to me in that context. So I think this has huge potential.
Yeah, and also
huge impact.
Yeah, and also one thing I also want to add is this: we were only opportunity to use the free tier of Cohere, and what amazed me the most was the amount of accuracy, how accurate it was able to, especially in the classification aspect. We had about 6,000 data sets to be able to test, train, and validate our model, but we were only able to use 50. And then from the look of things, just as you said that you tried it out and then it gave you pretty good responses. And also it was able to classify the motion very well. At least how much more we're only able to use 50, how much more if you now use about 5,000, we're having 54% accuracy with just 50 data sets. How much more when we now use about 5,000 data sets? That is times 100 of our of what we actually use to train our classifier. And also about the generator, I feel what really helped was the prompt engineering, the right prompt to be able to put into the generator to be able to give the right answer. Yeah, I think that's just what.
Well, thank you again. I think now we would move on to the next speaker, and another round of applause, virtual round of applause to Alleluia, please. Thank you so much for attempting to take on this huge and important project. And we hope that you would continue to make it better. And we look forward to following your progress on this work. So our last presentation for today, it would be from the multilingual semantic search at team by Team Zizi. The presenter for today is Abdul Gafar Toby Jimo. Do we have Toby all set up?
Thank you, Tajumade. I just needed to give me permission to share my screen.
Oh, yes, we just did that. Please go ahead. Thank you so much.
Okay, no problem. Sorry, just one moment. Okay, is it visible now?
It is.
All right, thank you. So my name is Abdul Gafar Toby Jimo, and alongside me on this project is Abdurrashid Balaji Lawal, and we are presenting multilingual semantic search for videos. What problem are we trying to solve? So we know that a significant amount of information on the internet is in video format, and it's freely available. For example, YouTube alone has 500 hours of video content uploaded every minute. Just think about the scale of that for a second. But you would also realize there isn't an efficient way to search through all of this video information. Yes, you can search YouTube itself, But once you get the video you're looking for, can you really search within the video to get the exact information you're looking for? That process is still very suboptimal at the moment, and in most cases, it's non-existent. So this is where semantic search comes in. It helps because even if you don't remember the exact term that was said in the video, if you just remember what something close to it, you can still retrieve that information you're looking for if you have an idea of what it is. And also the multilinguality of the Cohere's embed API makes it even more accessible because, well, now you don't even have to understand what language it was said in. You can still get that piece of information if you can, well, type it out in your own language. All right, so I just want to take this moment to stress the importance of multilinguality. So for example, multilingual approach for video search can help uncover more valuable and relevant results because, well, 500 hours of video being uploaded to YouTube, say every minute, cannot all be in the same language. What if we want to, scan through all of those videos and get information from them? Would have to account for all of the possible languages they would be in, which is where the multilingual embed model and being able to perform multilingual semantic search comes in handy because, well, it doesn't really matter what language they are uploaded in anymore. All of a sudden, you can just use one search term to get information from all of them. And it also makes crawling and indexing more efficient, which I have briefly explained in my last point there. So if you want to basically index all of those videos, which is the main premise of Google search itself, being able to index web pages, but for some reason, their videos are left unindexed in YouTube. So this approach will make it more efficient to crawl and index all of these videos, regardless of whatever language they were uploaded in. And also for the content creators, well, it can help them increase viewership and engagement if people are able to find their videos more and find it useful because they can find information they're looking for in them. So what exactly did we make? We literally just made a simple user interface that allows you to paste the URL for a YouTube video and also enter a search query and get every instance in that video where something similar enough to what you're looking for was said. And it also gives you the exact timestamp in which it was said and allows you to seek to that timestamp immediately. As you can imagine, before this, if you were to look for, say, somewhere in a video where something was said, you would have to seek through the video until you find that point you're looking for. But this makes it a lot easier because, well, you can just search for whatever you want to find in the video and you get the exact timestamp in which it was said. And I know YouTube has chapters for people. Those of you that use YouTube frequently, they do have a feature called chapters, but that one, it will involve the creator themselves indexing the video at specified timestamps. So if the creator does not cover the information you're looking for in the chapters they've indexed, well, it's basically useless to you because the feature is quite limited in its functionality. So, which is one of the main reasons why we thought about building this. So how do we go about it? Well, I have a simple flowchart here to talk about the process of being able to embed and index the phrases in a video and also allowing you to search for them. And along the line, I also mentioned the tech stack that we used. So first of all, we get the YouTube URL. We're using YouTube because it's the largest database of video available freely on the internet. We get a URL from the client, which is the UI I've shown earlier. I've shown a screenshot of it earlier. And we have a service that just downloads the video, making use of Python libraries. We also have another service that extracts the audio from the video. We're using Python libraries for this also, based off of the FFmpeg framework. Makes it really easy to do. We then send the audio to yet another service. This is an external API called DeepGram. It's a paid service, but they were able to give us a free version to use for this project. That then returns these transcripts with some metadata in it. So we then segment the transcript and do a little bit of pre-processing on it. The segmentation algorithm is custom. We segment them in a way we think the phrases make the best sense in case you were searching for something similar. And then we send that to Cohere's multilingual embedding API. So we get the embeddings back from the from the model, and then we save them somewhere alongside the metadata. So for once you enter the URL for a video, this is everything that happens within the backend of our system. So the embeddings are stored as soon as you upload the video. Now, say you come in and you type in a search term, you're looking for something. A very similar process happens to the search term you're looking for. So it's pre-processed and sent to the embedding API, and the embedding API returns an embedding source. So we use cosine similarity to see how similar your embedding is to sections of the transcript that we've segmented. So we then rank the top 5 most similar embeddings or phrases that have similar embeddings to your search query. That way we're able to find moments in the video where that piece of information exists. Or of course, there will be instances where there wouldn't be good enough matches. And in that case, we just don't return anything. So return the matches and the metadata, which is basically the timestamp in which that information was said, back to the client. And that's what you can see on the screen. At the end of this presentation, we'll do a short demo so we can show you guys how it works. All right, so what did we learn from this project? Well, first of all, it gave us valuable exposure to multilingual embeddings, because this was the first time either one of us was interacting with a multilingual embedding. And one of the main things we learned about these embeddings was that, well, they are basically one-way vector computations, and they are not really useful in, I wouldn't say totally useless, but in tasks that involve bidirectional encoding and decoding, like translation, they come short. But as you can see from some of the projects that have already been demoed before us, there are still ways in which you can use them to accomplish such kind of tasks. But we did enjoy playing around in Cohere's playground. I think it helped us develop faster because we had a short turnaround time for this project. We basically had just Friday and Saturday to ideate and develop this before we had to submit. So having the playground was a lot more useful than having to read through the documentation while writing code, while making the slides, while doing all of that. So the playground was extremely useful in our development process. Also, we realized that even though the multilingual model is state of the art at the moment, it struggles with some languages, especially Yoruba, because both of us are Yoruba speakers. We try to test the model extensively in Yoruba language, and we noticed that in some cases, now we don't really know why this is the case, but in some cases, it just comes up with embeddings that are totally not related to, say, the translation of that search term in English. This is something to keep in mind, but there are instances where it works very well, and it's really useful in helping you bridge that language gap when you're doing your search query. And we theorize that this is due to lack of proper documentation and standardization of some of these African languages, because, well, in the case of Yoruba, for example, the way I would type a sentence in Yoruba and the way the next person would can be slightly different, because even though we both understand the same language, the way we would write it down would have a little bit of difference. And also that affects the kind of result the model will give back to you, basically. So if there was a standard way, or if, well, there was a much more generally acceptable way of, people typing out Yoruba, it will help, especially when we have tools like this that can help us index and access information faster. We'll be able to take, it won't take away from the value of what this model can provide to us, basically. So where do we go from here? Well, the most popular use case we've thought of is enabling people to search through long form content on YouTube so they can access relevant information faster. We also thought of building a browser plugin for YouTube, basically for the same purpose I mentioned in the first point. Yeah, regarding the shortcomings in terms of some of the languages it doesn't recognize properly, we're not entirely sure about the possibility of this, but we think fine-tuning the embedding on some of those languages would help improve the results, because well, from our testing, we think it's not it's state of the art, but it still falls short in some cases where you're looking for terms, for example, things that are not easily translatable to Yoruba, say, for example, technological terms like that. It falls short in those instances. Also, being able to do audio translation alongside video lookup would be very useful, because we realize, well, if you're searching for content in a separate language than, English, you probably want to also hear that content in that language. So if, a one-stop shop that just detects what language you are using to search for that content and plays you the audio in that video in that specific language will be extremely useful. And that's one thing we're considering, one functionality we're considering adding to this. Also, video upload functionality here, this is actually slightly poorly worded, but what we intend is being able to search through video that's not hosted on YouTube at the moment, but say you have a video or a movie even on your computer and you want to figure out what part of the movie, say a part of the script was said in, you could just upload that to this software and type whatever your query is in the search term, instead of having to look through the entire movie itself to figure out what part you're looking for. So that's something we are considering adding. In fact, that was actually what we initially planned to do. But because of the short turnaround time, we had to use YouTube because, well, there are readily available Python libraries that let you get a lot of information from YouTube in very few lines of code, rather than having to process the video from your computer itself. But this is, if we're going to start implementing any of this, we'll probably start from the bottom up. All right, so at this point, I'll just let my colleague take over and do a demo of what we've built to you guys. Okay, as you can see on Rashid's screen here, we have the same user interface I've shown to you guys earlier in the presentation. So you basically just have two search boxes there, text boxes, sorry. One where you can enter a YouTube URL and the other for your search query. So if you could just put a YouTube URL in there so we can get a video from YouTube. All right, so this is a video from Marques Brownlee talking about a phone, basically. And if we want to figure out what part of this video he talks about the quality of the screen of the phone, you just go into the search box and type screen quality or quality of the screen, however you want to word it. Oh, display, good. And you can see all the points in the video where he talks about the screen of the phone here. So this allows you to be able to go straight into those places instead of having to watch the entire video to figure out what parts of the video it talks about the screen of the phone. And also, like, you could also get similar results if you enter the search term, say in French or a different language. All right, thank you for the demo, Rashid. I don't think, was anyone able to hear the audio from the video? I couldn't hear it myself, but I think that's sufficient.
Wow. Thank you so much, Rashid, for the demo, and thank you, Abdul Ghaffar, also for the presentation. A virtual round of applause to the team, please. And we'll take some questions since this is our last presentation for today. So feel free to share your thoughts on this project or any question you may have. Do we have any comments from the audience or questions? So personally, I enjoyed playing with this. I also tried the demo. Did I try it? I don't think I tried the demo exactly, but I thought that, like, when I was looking at this, I thought about like how it's going to make a lot of life easier. Now I'm trying to think, did I try the demo? Did you provide the demo link? I don't think so, right?
Yes, you can. We actually hosted it on GitHub. You can go to the GitHub repository and try it out yourself. There's instructions on how to set it up. And
Yes,
come across it.
exactly.
Yeah.
Yes, I wanted to try the demo and then it's needed to be set up. It was not like on Streamlit or anything like that. Yeah, I think that was it. I was hoping to try the demo. Do you think you could maybe put it on Streamlit as well
We
to
did,
for people to
actually, we did. And in fact, that set us back a couple of days. Like I said in the presentation, we started building this on Friday. So we tried to use Streamlit for, say, the first few days, but we realized the video functionality on Streamlit is very, very limited. So even if we're able to get, the results from good results from the multilingual embedding, we cannot really make use of those results in the video. Streamlit can just play a video from start to finish, cannot let you seek, you can't really do anything with videos on Streamlit.
I see,
So
I see.
yeah, it has
Okay.
limited functionality. So we had to build our own user interface and video hosting.
Okay. So do you have plans to make this a tool that people are able to use? You talked about making it a YouTube plugin, for example, in the future. Maybe that's the direction the team is looking to take this project.
Yeah, definitely. It's something we both have personally used ourselves since we've built it, and we think it's going to be really useful for everyone. I'm not exactly sure why video hosting platforms like YouTube have existed for close to 2 decades now, and this functionality isn't present in them yet. So we think everyone needs to have this. We'll try to get it out there as soon as we can.
Well, thanks a lot. We will be looking forward to it as soon as we can. So I don't think there's any other questions or comments. I think the next thing on our agenda would be for judges to take a 10-minute break to reflect on all of the projects and then come up with a ranking. And afterwards, we would announce, Roy Lim would be given the announcement and unveiling the winners and the ranking of the winners, because you're all winners. Thank you for presenting. So let's take a 10-minute short break, and I hope that everyone will get to know one another better virtually while we take a break. We'll be right back. Hi, everyone. Thanks for sticking with us. And now we are back. And I'll be handing over to Roy Lim from Cohere to do the honors of unveiling the winners and ranking them. This is a tough job, Roy. Thank you.
Yeah. Wait, are we ready?
Yeah, we're ready. You can share your screen once you're ready.
Are you sharing or am I sharing? Why don't
You can.
I will just say a few words and then you can share and then I will. Shall I?
Okay. All right. Great. That sounds
Wow.
great.
Okay, everyone, just want to say this was really, really difficult for the team and I to really look through. Initially, I came in with some idea of like who I think is going to be outstanding, but after really hearing your pitch and answering really like questions from us, like, you know, this changed some discussions and hearing Teju and George. So I just want to put it out there that, you know, obviously there will be some winners, but, you know, this is really a tough decision and really great job to every single one of y'all. Thank you for taking your time out to present. Thank you for your dedication and passion and interest in the field of AI. This is only the beginning of like what is to be many years to come, like would really be a game-changing revolution. As our CEO Aidan Gomez has mentioned before, it's almost like the industrial revolution, and like this is huge. And so I'm so inspired seeing all your work. Thank you for the amazing, amazing, amazing hackathon. Thank you to Teju, George, JJ, Tola, and so many of the teammates who, and many other communities who were part of this. Without you, like, we were not able to organize this incredible hackathon. We spent 3-4 long months planning for this. So it was truly, truly an honor to collaborate and work with you. Yeah, so, oh my gosh. All right, so just want to recap on the prizes for everyone. Let's look at the prize. So first place, we have $1,000 USD with 3,000 Cohere API credits. You will also, after this, we'll reach out to you to meet with one of our Cohere founders or the leadership team, and we'll build a demo package for you to showcase on social media. Second place, 800 USD, 2,000 Cohere credit prize. Third place, 500 USD with 1,000 Cohere credit prize. We have, because you guys are so amazing, we came up with a fourth place, 200. We're going to throw in a 200 USD with 500 Cohere credits. And of course, we have a popular vote for honorable mentions. There will be one from the top 5 that will also be part of the honorable mentions. Now, Teju, would you like to say a couple of words now before we announce honor? Do you want to announce honorable mentions?
I don't have much to say. I just wanted to say that this has been truly incredible, and we really do hope that a lot of these projects would turn out to be the beginning and the start of amazing industrial revolution in the future. So without further ado, Roy, I think we should get on to the prizes and
okay. All right.
Share with us. Who are the honorable mentions? Da-da-da-dun.
Okay. I think we have honorable mentions. We have internal health. You guys were really amazing. Thank you so much for your idea. You know, this was a great proof of concept. You know, there is a lot of potential in this. You know, mental health is a really tricky topic, and, you know, this requires a lot of focus group study, user testing, you know, and, you know, fail-safe responses that we need to look into in the future. But as a proof of concept, this was really, really a good demo. Please don't, you know, ever doubt yourself. We still want to recognize it was really tough decision. So congratulations, internal health. And the popular vote goes to Bible app. I'm not sure if they're here, but if they're listening on the live stream, congratulations as well. Yeah, okay. Wait, I think we don't have animation for the third prize, right? So the third prize goes to a fourth prize, our new category prize. Fourth prize, because this was so amazing, goes to multilingual search video. Congratulations. This was a really good idea. You know, I can see global companies utilizing this to enhance productivity and really, like, I see a lot of growth within that. I will use that if it's available. So I really hope that you all work on this project after this and show this to us in the community on Discord. And I reckon you to try other endpoints fusing them together as well, right? Because I think these are going to be very handy in the future, especially for meetings and companies out there. So congratulations to this team. All right, third place. Congratulations to Omaway AI. This was really, really awesome. You know, well done. This is a perfect example of like weaving several endpoints and use case that can be utilized in different ways. The presentation was really great. It was easy to understand. I can tell that your team spent time properly thinking through the solution and enhancing learning for your communities and students. This was a really, really great project. I'm really excited to see how this can grow and benefit other people in the future as well.
Okay, now we have two teams and the pressure is on, right?
Yes, yes.
So
yeah.
the second place winners goes to, right? You want to kick it off to tell us how we unveil it?
Actually, second place winner, drum roll, goes to
okay,
reveal. Congratulations to Cohere Parallel Language Sentence Alignment. Means that the winner is our document co-finder. Congratulations, everyone. This was really, 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 really impressive. I'm going to talk a little bit about Cohere Parallel Language Sentence before going to y'all as well. You know, we have Louisa, who is a research scholar in C4AI. She mentioned that this would really set the tone for our second place winner, like many other apps that will be leveraging on this in the future. So we really encourage you to reach out to the C4AI community because we would love to explore more research projects with you in the future and really following your journey as well. This is really going to lay the groundwork for a lot of the great work that will be built atop in the future. And these data sets are going to be very beneficial. And we're really impressed by the scoring and the benchmarking. So congratulations to you. And of course, the winner of the AI Saturday Legos Multilingual Embedding Hackathon. Congratulations to Document Co-Finder. You took the inspiration from, you know, like LNU Co-Finder, but really like enhancing this in so many levels that, you know, I see this as its own product in itself that can be utilized across so many companies. And this is a use case that I would love to sort of explore with you further down the line and seeing how this can grow, this can benefit communities broadly and even businesses as well. Re-rank was something that we released. I loved how you guys incorporated it and realized that this could be beneficial as well. And multilingual just complements this perfectly. So congratulations.
Wow, this is amazing, right? Like this is incredible. Thank you so much, everyone. And of course, you would be working with Royston now to build a demo package and having a great, what I hope would be a great conversation with one of the founders of Cohere. And you know, really great job, awesome job, everyone. Like Roy said, this was really a tough decision to make. We considered a lot of factors, right? How ready do we think these projects are? Like, what are the potential of this project, you know? But we can only judge based on what we see. We are not future seeker, you know. One thing that you think maybe the first place today, maybe like fourth place, maybe like a hot shot in the future. So this is by no means meant to categorize your artwork into saying that one project was much more important than the other, but merely what we think would really benefit the most from based on the criteria that we have set for this hackathon. We're really grateful for your time, and thank you to Cohere so much for trusting us to partner with us, for helping us flesh out these ideas, and that's why I want to go into the keynote speech to reflect a little bit about this journey. Rai already hinted earlier on that we spent 4 months on this. It's been a long time, and we're just so grateful that it came out. It's like everything came together so perfectly, and that we had such great turnout. And thank you all for dedicating your time, for being interested in this topic. And we hope that our future, we would get to collaborate much more in future hackathons. So where did we start? Like this hackathon, we started with some cool workshops, right? We wanted to make sure that people are familiar with Cohere, people understand what we mean by embeddings. We gave a series of talks, like Luis Sereno gave a talk on large language models for real world application. We had talk from David on news topic classification for African languages, and so much more. We talked about semantic analysis for African languages. So I think this series of workshops that we had before we started the hackathon was meant to educate our like all our audiences, like the participant. And from what we gathered from you all, like a lot of people found these workshops to be very, very helpful to help them understand how to better use the tool. So thank you so much to all of our speakers, George, our virtual speakers as well, like our pre-recorded speakers. Like all of our speakers were virtual, except Sarah. She was in person plus virtual, but we also had a lot of pre-recordings, and we just wanted to thank Cohere so much for sharing this resource, great resource, to help us better ground all of the participants' knowledge in the context of the hackathon problem that we aim to solve. So we have so diligently collated all of this resource on our YouTube channel called AA Saturdays Lagos. We have a dedicated playlist for it. You can scan the QR code, or you can go to bits.ly/Cohere AI hack, and you would see all of the videos, about 27 videos, including all the demos from all of the projects, except one. So you can see everything on the YouTube channel to help you go back to it and reflect on this hackathon journey. And also after like our workshop, we also organized office hours where some of our mentors took their time to chat with us for 1 hour on different days. We had Oreva Ayer, who is a PhD student from University of Washington. It takes some time. She researched NLP, and she was very happy to join us, to chat with the team, to be able to offer any kind of insight or like help that the team may need. So we really just want to thank all of our mentors. We also had Yosha Kupers, who is a PhD student from CISPR, who also held an office hour, and also another of our mentors, Met Money, who also organized one office hour. George, Rahimat Tola, and Tayo. I just wanted to say thank you so much. And the biggest shout out, I think, goes to Rahimat Adetola Adetunji, because she was the one coordinating and co-organizes these mentors office hours. A lot of us might have seen a lot of emails from Tola as well, like encouraging us to join it. We hope that this resource that we have provided to you were very helpful, and we really, really, from the bottom of our heart, thank all of the mentors who took their time to share to offer some guidance to our hackers. And apart from the office hour, the virtual hackathon that happened for a week, we had in-person hacking events across 5 different communities, which was incredible. We had over 30 participants from Arewa data science community, forming 8 teams, hacking. We really, really do appreciate the organizers of the Arewa data science community for mobilizing their community members. Thank you so much, guys. This was incredible. Mubarak, I have to shout out to you, especially because you've been an incredible source of inspiration to your community members, our community, like all the hackers, participants, trying to offer guidance and support however you can. We also shout out to our sister community, AI Saturdays Ibadan, for their incredible work. Ahmed, thank you so much for being a champion and a leader. We've worked together so many times in the past. We've known each other for a long time, and we are very I'm very, very grateful to see all of the work that is going on in your community. We've been also, our community have been a huge inspiration, and I know that we'll continue to work together. And I also wanted to thank all of the co-organizers from ASS Ibadan, right? We Abdusalam, and also we thank you for all of your support from graphics designing, and also for being just a huge advocate, making sure that your participants, your community members are also represented and then produce work, right? And you see, one of the finalists was also from your community. So just wanted to say, great job, guys. We also had other communities from CMU, Africa Data Science Club. This partnership was championed by Tayo Jabbar, who was the former president of the CMU Data Science Club. But I also have to shout out, from the bottom of my heart, thank the team from the CMU Data Science Data Science Club, Gail, and everyone who was involved in the organization. We're really grateful for your support, for mobilizing your community members. I was there in person and blown away by the level of organization that was going on there. And so thank you so much for accommodating us, for also having Sarah present in person. This has truly been incredible to get to work with all the team across different parts of the continent, right? So I also wanted to shout out to AI Saturdays in Abuja. We also had a good turnout. We were expecting a large turnout. We had less than we expected, but I think this was also we're very grateful for the connection that were made by the people who went in person to collaborate. And we hope that this has further strengthened the connection between participants. That's one of the hope that we had for this in-person hacking event, to make it much more to go beyond the virtual connection, more having people gather together in a place to hack together, to brainstorm on a problem together, and so much more, and also to collaborate across different community. And finally, I want to shout out to my team at ASS the Lagos. George Antola pulled up the incredible organization for the community in Lagos, and we really appreciate everything that we've been doing. And of course, apart from us co-organizing in Lagos, we're also co-organizing across the different community and different countries. We truly could not have put this together without a team effort. Everything that happens out of the goodness of our hearts, if I can put it that way. We've always held free to attend classes across all of the communities. This is very, very present, and so just so grateful for your work, and thank you. And we continue to push this mission forward. Like I said, it takes a village. It takes a lot of people to get everything rolling. So I just wanted to shout out to the team. We had different multi institution collaboration. You can see you have Cohere here, Tix Africa, ASS Desibado organizers, Lagos, also CMU, Africa Data Science, community organizers. We have organizers from also from Iowa Data Science, Academy, and like different guest guest speakers like David, Shamsuddin, and so on. Like, this is not a full list of teams. So this was a huge endeavor from different people to make this a possibility. So thank you so much, guys. And so yeah, just this is where we're coming to the end of this this hackathon. I just wanted to tell you again that ASS Lagos is a community of learners. Our aim is to help you to kick ass in AI. And what we mean by kicking ass in AI is being so grounded in the knowledge of machine learning and data science, and also building products for our community and beyond, you know, being able to be at the forefront of this AI technology. So we do this by organizing cohorts, like 16 weeks classes where we teach up to date since our founding in 2018. We've organized 7 cohorts, like that's over the span of 5 years. And we are also planning our 8th cohort, like which we would be advertising in a few weeks or months. It takes time to organize a lot of these events, and we're very grateful for our co-organizers, Lawrence and Tayo, who would be taking on this huge and responsibility of leading the organization of the cohort 8 effort. And we also have an event coming up. Actually, it would start next week, Saturdays, for people interested in edge computing. So this effort is championed by George, one of our co-organizers, and it's going to be in person. So you'll see everyone, you meet more people. So we hope that you would sign up. We can share the link again for you to sign up, but yeah, please do. You will learn a lot about edge impulse technology and video Jetson technology. So edge computing is one of the field that is of high interest now, and it's also one of those fields that has a lot of potential in our ecosystem. So it's really this is the best time, I think, to get into this field and to learn more about it. So I encourage you all to apply and to continue to follow our progress and our journey at ASS Lagos. This all hackathon, the Cohere AI hackathon, would not be possible without our sponsors and our community partners, our supporting partners. And I just want to say thank you so much, everyone. Thank you. And we hope to be collaborating to continue to organize together to move our society, our ecosystem, our community forward. This is Cohere AI Hack. Thank you for participating. Bye-bye.
Thank you. Bye. Bye, everyone.
Bye.